We will conclude our study of polynomial rational functions by looking at modeling using variation. If x and y are related by an equation of the form y equals k x to the n, then we say that the relationship is a direct variation and y varies directly with the nth power of x. In direct variation relationships, there is a non-zero constant ratio, k equals y over x to the n, where k is called the constant of variation or the constant of proportionality. The quantity y varies directly with the cube of x. If y is 25 when x is 2, find y when x is 6. So, the first thing we need to do is set up the model. It'll be y equals kx cubed, and we need the k. Well, we're told that y is 25 when x is 2. So this means that 25 is k times 2 cubed, or 8 times k. This means that k is 25 over 3. I'm sorry, over 8. So the model is y equals 25 over 8x cubed. We can now use this model to solve the question, if x is 6, what is y? So we want y of 6. So this is 25 over 8 times 6 cubed. And this is 675. If x and y are related by an equation of the form y equals k over x to the n, then we say that y varies inversely with the nth power of x. In inversely proportional relationships, or inverse relationships, there is a constant multiple k, which is x to the n times y. This is called, again, the constant of variation, or the constant of proportionality. So the same example as last time, except now it's going to be inversely variation. So a quantity y varies inversely with the cube of x. Y is 25 when x is 2. Find y when x is 6. So y is equal to, this time, k over x cubed. So this means that 25 is equal to k over 2 cubed, which is just k over 8. So this means that k is 25 times 8, which is 200. So y is equal to 200 over x cubed. So now we can solve the problem, which is, what is y when x is 6? So 200 over 6 cubed. This is 25 over 27. The final type of variation is called joint variation, and this just simply occurs when a variable varies directly or inversely directly, or possibly both, with multiple variables. A quantity x varies directly with the square of y and inversely with the cube of z. If x is equal to 6 when y equals 2 and z equals 8, find x when y equals 1 and z is equal to 27. So the model, so we have k. Then we know that it's going to vary directly with the square of y, which is y squared, over inversely with the cube root of z. Now when x is 6, or x is 6 when y is 2, so this will be k times 2 squared over the cube root of 8. So it's k times 4 over 2. This is just simply 2k. This means that k has to be 3. So our model, x is equal to 3y squared all over the cube root of z. So x, when y is 1 and z is 27, we get 3 times 1 squared all over the cube root of 27, and this simply 1. And that is really all there is to variation. Real simple, short video this time. That concludes our look at variation. This also happens to conclude our look at rational and polynomial functions. So next time we will begin looking at exponential and logarithmic functions.